All right, so let's talk about factoring. Right now, we're going to focus on factoring using a greatest common factor. Now, a factor is something that you can divide by, but still get no remainder, no decimal. Okay, so in this first one, we're trying to look at, is there a factor of 7x squared and 3 that they both have in common? In this case, both 7 and 3 are prime. Only one has the variable. So the answer is no. There is no common factor here. However, with 6x squared plus 3x minus 12, each of them has a factor of 3. We could divide any of them by 3. And so, yes, there is a greatest common factor. There is something we could take out. This next one, once again, we got 3 and 7. Those are prime, so they're not going to share anything. However, they both have x. And so we could divide both of those by x. So, yes, they do have a common factor. 2x plus 6x squared. Once again, both of them have x. They also both have 2's that could divide by. We can do 6 divided by 2 and 2 divided by 2. All right, so now we're actually going to do the factoring. All right, so for 45x squared minus 25, greatest common factor is going to be a 5. So what I'm going to do is divide both of these by a 5. And that's going to tell me what I put inside of this. So I'm going to have a 9x squared and then minus just a 5. So I've now successfully factored that, took out the greatest common factor. Next one, looking at what I can divide both of these by. I see both of them have an x cubed. And then we've got an 8 and a 4. So I could probably divide both of them by 4. So I'm going to get a 4x cubed. Then on the inside, that'll just turn into 2y squared plus 1. And now that one's factored. All right, final one. I do see that we've got an n in both of these, so I'm just going to put that in there right now. And then a 6 and a 4, we can divide both of those by 2. So what I'm factoring out is a 2n, which is going to leave me with 2m to the power 4 n minus 3. All right, so this has been factoring using the greatest common factor. But we're going to get even more complex. Now, we're going to see a new example. This is called the difference of squares. Now, it's important as we talk about difference of squares to realize that we've got a very specific format that it's always going to take. So first and foremost, it's just right here. It's going to be some square number minus another square number. And that's important in order for this to work. So if we look at number 1, we got x squared minus 21. So in this situation, a would be an x. And it looks like b would be 11. 11 times 11 is 21. Now, once I've identified both the a and the b, I can just use exactly what they gave us up above. Quantity of a plus b times the quantity of a minus b. So this becomes x plus 11 times by x minus 11. All right, now in number 2, I could have a be a 2x. I could have b be a 13, but I still can't do it. I can't use this method. The problem is with plus. I am not doing a difference of squares here. So when I'm trying to do my positive and my negative multiplied together, that won't work because this one actually is supposed to end up as a positive. So right here, the answer is no, can't do it. All right, I can do x to the power of 4 squared, and that'll give me x to the power of 8. However, 5 here, that's a prime. I can't multiply any whole number by itself and get 5. So this is also just no. We're not going to use difference of squares here. 100x squared, my a could be a 10x. My b can be a 3. We are subtracting, so this is going to work. So we do our 10x plus 3 times 10x minus 3. All right, m squared, a could easily be m. b, 24 is not a perfect square. And so I don't have any whole number that multiplied by itself gives me 24. So no, we would not use difference of squares here. 64 for our a, so that means a could be 8. 25c squared means that we're going to have 5c for our b. We are subtracting. This is a difference of squares problem, so this will be 8 plus 5c times by 8 minus 5c. And that's difference of squares. It's important to note where it can be used and where it can't be used. If I'm not subtracting, I can't use it. If both of our terms are not perfect squares, I can't use it. But if we meet both of those situations, it's a simple setup of saying the quantity of a plus b times the quantity of a minus b. All right, now factoring by grouping. Mostly I use factoring by grouping when I am looking at a cubic, that means to the power of 3 polynomial. However, it can be used in a quadratic situation where we've got just to the power of 2 for our highest degree. But we're going to focus first on how it applies to the cubic problem. Now, I'm going to separate out my terms. I'm going to put them in order of highest degree, but I'm going to separate them out into 2 groups. Now that they're separated out into 2 groups, I'm going to do what I did in the very first problem. I'm going to look for the greatest common factor. So between 8r cubed and 64r squared, both have at least 2 r's in them, and both have 8. So I'm going to have 8r squared, so that means we'll have on the inside of that r and a minus 8. Okay, now my second one, there's really not a common factor there, but everything has at least one common factor, and that common factor is 1. All right, so 1 times r minus 8 would still be r minus 8. So one thing we should note, we got an r minus 8 out of both of those. R minus 8 just became a common factor. And so we can now write that as r minus 8. We just took out our common factor, put it in front, multiplied by 8r squared plus 1. All right, so now that we've done that, I'm going to erase this so that I can focus on the next problem. All right, so once again, first 2, second 2. Looking for the greatest common factor. So I'm going to have 2x squared, which it becomes a 6x plus 1. Now the next one, our minus 30x minus 5. We could be tempted to say that the greatest common factor is 5, and I would agree. But one thing I want you to notice is that this is a 6x plus 1. It's positive. Now, both of those are negatives. And so if I actually take out a negative 5 instead, what I'm going to end up with on the inside will be, once again, that positive 6x plus a 1. So in this case, I definitely want to say that it's not just a positive 5 that is the common factor, but that negative 5. All right, so we got 6x plus 1 just became our common factor between the two of them. So 6x plus 1 multiplied by a 2x squared minus a 5. I like to use these colors so that you can see where everything came from. If you are writing your own notes, please use highlighters. Make sure you know where every single number came from. All right, now we're going to move on to the quadratic. Now, the issue with the quadratic and doing grouping is usually we've talked about doing the first two and the second two. Well, we've only got 3 terms here. We've only got a trinomial here. So in order to do this, we're actually going to have to separate it out into 4 terms. The way I pick those terms is by taking my leading coefficient and we're going to multiply it by the constant that we've got there. So 8 times 15, that's going to give me a 120, and now I want to start listing out the factors of that. So 1 times 120, 2 times 60, 3 times 40, 4 times 30, 5 times 24, 6 times 20, 8 times 15, and finally a 10 times 12. Now, it's also important to note here that what we have here is a positive. So if you look at my other video on factoring, what that right there tells us is that both of our situations are going to have the same sign in them. We're either adding in both or we're subtracting in both. In the end, it means that whatever factors we have, they're going to be added together to get our middle number right here. So I'm looking at all of my factors that I've just listed and seeing which of them would add together to give me 22. Well, 10 and 12 are going to give me 22. Now I'm going to use that fact to expand this out in a different way. So we got x squared plus a 10x, that's where my 10 comes in, plus the 12x plus a 15. Now, I chose 10 and 12 from my list because it would equal the 22, and that's where my 22x just went. I just separated it out into a 10x plus a 12x. This now allows me to use grouping by factoring. So we're going to take out a 2x from the first one, leaving us with 4x plus 5. Next, we're going to take out a 3 from this next, and we'll get, once again, 4x plus 5. Well, we now have a common factor that we can take out. So 4x plus 5 times by 2x plus 3. And we have now factored a quadratic equation using grouping. For more on dealing with quadratic equations, see my other video on factoring. All right, now this is the last that we're going to do. This is a situation called the sum or difference of cubes. Now a cube is any number multiplied together 3 times. So 1 cubed is 1 times 1 times 1, which is 1. 2 cubed, 2 times 2 times 2, which is 8. 3 cubed, 3 times 3 times 3 is going to be 27, and so on and so on. Okay, so let's now take these. We've also got this situation right here. It gives us an equation to use, and once again, we just need to identify our A's and our B's. And if we can identify what A is and what B is, and it fits the proper form, then we can just plug it into an equation. All right, so A here would just be x. X times x times x will give us x cubed. B will equal 5. 5 times 5 times 5 is 125. So now I'm also going to be looking at, this was a plus, so that's a plus. So I'm going to be using that formula right at the top. I'm just going to follow it exactly like it was. So at the top we add a plus b, so that becomes x plus 5, times the quantity of a squared, which is now x squared, minus a times b, so minus 5x, plus b squared, so plus 25. And we're done with that one. I just needed to plug in the numbers just like they were. Here we got a cubed. Well, that's convenient. A is just going to be a. We got 64 here, so that means b is going to be an 8. 8 times 8 times 8. Or, sorry, not an 8. Hopefully you guys figured it out before I did. 4. So b is going to be 4. Now this time we were subtracting, so I'm going to be using the bottom version of this. So it starts with a minus b, so a minus 4, multiplied by the quantity of a squared, plus ab, so 4a, plus b squared, 16. And we're done with that one. We just used the sum or difference of cubes. We got x cubed here, so a is going to be x. And we got a 1 there. Well, that one's nice and easy. B is just going to be 1. We are subtracting, so I'm going to use my bottom equation, which matches up. And so now I'm going to have, starts out with a minus b, so x minus 1. And then an a squared, so x squared. Plus ab, so plus 1x. And then plus a b squared, so plus 1. All right, final and most tricky one. We got 343 m cubed, which means that a is going to be 7m. Next, 64 n cubed, so b is going to be a 4n. All right, so two factor. We do see that this one is plus. I'm going to be using the top one in this situation. So a plus b is going to be 7m plus 4n times by the quantity of a squared, so 49m squared. Now minus a times b, so that'll be a 28mn. And now add a b squared, so plus 16n squared, and we factored it. Now, these are just a few of the ways of approaching factoring. Please make sure that when you're using these methods, that everything lines up. We can only use sum or difference of cubes if both numbers are perfect cubes. If I was using a number like 15, That's not going to work because I don't have a whole number that multiplied 3 times is going to give me 15. Just be careful with that and you'll do just fine.